Hello, everyone, and welcome to our webinar for PropCad Premium, design of patterns with PropCad Premium. I'm going to share the desktop so that we can go through a brief presentation, and then we'll do a demonstration of the creating a pattern within PropCad. All right, everyone should be able to see the PowerPoint on the screen, and I'm going to continue to proceed through here. First of all, I want to thank everyone for attending the webinar. We're going to discuss some of the new features in PropCad Premium, and we're going to demonstrate this pattern corrections utility, a new feature that's been added to our PropCad Premium edition. We're going to briefly touch on what a pattern is and the casting. Maybe. We're going to briefly touch on what a pattern is and the casting process. We're going to review the different geometric changes that are involved that occur during a casting, and we're going to go through the geometric corrections in order to create a pattern. After that, we're going to do a demonstration within PropCad of the pattern corrections utility, and then we'll do some conclusions and discuss what's coming up in the schedule for HydroComp. For those who don't know, PropCad is software for the geometric modeling of marine propellers. It provides tools for the automatic preparation of 2D design drawings, 3D views, construction data, geometric properties, and of course, CAD/CAM file export and import. We currently have over 150 users in 40 countries, and we continue to grow PropCad each year with new features and new additions, including the PropCad Premium Edition. This is the PropCad interface. Many of you are familiar with this. I just want to briefly touch on the main window here, the main principal parameters of the propeller, including number of blades, diameter, and pitch, a summary of geometric characteristics, the 3D viewport, and of course our sections data down at the bottom here. This is the main interface of PropCad, and we're going to explore some of the utilities inside. Specifically, we're going to explore the pattern corrections utility. Again, this is part of our PropCad Premium Edition, which includes a few significant new features that have expanded upon the capabilities of PropCad in order to support more of the manufacturing, production, and inspection side of the propeller community. The pattern compensation utility helps to build a pattern geometry from a PropCad design. It provides the means to create new pattern geometry with additional offset stock for machining and finishing, as well as user-defined scaling factors to account for distortion and shape changes during the casting process. Scan Converter is another significant feature of the Premium Edition. We're going to go through this utility next week, but Scan Converter allows you to use scan data from a CMM machine or a scanning device, basically XYZ coordinates, and we can convert those 3D coordinates into a 2D section shape and derive all the geometric parameters. But we'll talk about that next week. So why do we need a propeller pattern? This is because there are geometric changes that occur during the propeller casting process. We need to compensate for the specific material that we are casting the propeller out of. During the casting process, the hot molten bronze will go through a series of shrinkages, resulting in a smaller effective size. We also need to account for the different surface issues. For instance, we need to make sure that there's no slag, porosity, or inclusions, such as we see in the middle figure, and we need to be able to remove any of those defects through our finishing operation, whether that's CNC machining, hand finishing, or grinding and polishing. There are four major geometric changes that occur during the casting process. When the hot liquid material is first poured into the mold, it will begin to cool. The liquid itself will shrink as the liquid is cooling. At a certain point, the material begins to cool to the point that it will solidify. The solidification of the liquid to the solid also is an additional shrinkage that we need to be concerned about. And lastly, once the propeller has solidified, it's still hot. As it cools to room temperature, we'll see an additional shrinkage due to the thermal effects. The last major shape change is what we refer to as distortion, and this is unanticipated changes in shape due to thermal effects and other stresses that occur while the propeller is solidifying progressively. There's also accounting for the surfaces. We need to remove any sort of defects on the surface, and this means leaving additional machine stock for machining, grinding, polishing, etc. There are three primary geometries that we're going to be concerned about. The initial geometry is our design. The design includes the drive surfaces, and this is used to prepare our drawings. It's used for gauges and inspection data. The machining geometry is basically our CNC stock model, which would be used to develop tool paths, robotic polishing methods, etc. The pattern is actually the geometry that we use to create the mold cavity that includes the stock offsets for the machining as well as the shrinkage factors for the casting process. We're going to now show how we can create all three of these geometries in PropCad using an existing propeller design. What I'm going to do now is I'm going to switch to PropCad 2016. We can see the initial propeller that we are going to create a pattern for here. It's a 42-inch by 42-inch wheel, and we'll be assuming that this is essentially nickel, aluminum, bronze. We're going to go to utilities, and we're going to pull up our pattern corrections utility. It's a separate utility from the main PropCad window, and it allows us to explore the changes in our model without affecting our current project. There are several different ways to visualize the model. We can have a wireframe, or we can also view it as a solid overlay, and I'll show you this in a minute here. Because there's no changes to the model, the corrected pattern and the original design are completely coincident, so we get this effect here. But as we add material to the face, I'm going to add 1/8 of an inch to the face and 1/8 of an inch to the back so that we can see these changes. I'm also going to add 1/8 of an inch to the outline. That means I'll be expanding the chord lengths by 1/4 of an inch and also expanding the diameter by 1/8 of an inch. The next option here is the extrapolation method for expanding the blade. Because we are actually extrapolating the chord lengths and the tip, we need to say how we're going to do that. We can use a pure extrapolation, but when you have a rounded tip propeller, the surfaces at the tip are all converging, and it can be difficult to extrapolate, so we suggest using a simplified method for the tip. We can also individually specify the material offsets for our hub, and I'll add 1/8 of an inch to the hub length and the hub diameter. For now, I'm going to leave our pattern making shrink factor 0, and I'm going to just calculate the geometry so we can see the expanded, what would be the machining model here. Once we calculate our geometry, we can see very closely that the surfaces are offset and ready to be input as a machining model. If we hit OK, it's going to prompt us to save these changes to our file. So this will allow us to record the different offsets that we added to our face and our back and the outline to create this specific model. So in the future, when we go back and we revisit a similar project or this project, we'll have good documentation as far as what we used for stock offsets to compensate our model. I'm going to hit yes here, and this model is going to be brought into PropCAD. We see the original propeller here. As soon as we recalculate this, we'll see a slight expansion of the geometry as PropCAD builds the expanded, thickened design. From here, we can go in and manipulate any of the distributions that we want. We can see that the face has been expanded past the baseline here, so we can see evidence that our offset stock has been added in correctly. At this point, the propeller is just like any other PropCAD project. We could go in and manipulate our distributions if we had to, and we can scale and change this just as anything else. I'm going to save this project now, our 5 machining model. This allows us to keep our files separate, so we can always go back and open our original design file, and we should have all of the stock offset information saved. Open up the pattern utility. Again, we'll see the offsets, the stock offset data already entered for us. It's saved to the original file. So this allows us to go in, and now we can specify our shrinkage factors in order to make our final pattern. The shrinkage factors are specified as a multiplicative factor. So if we wanted to add 5.5%, the multiplier is 1.055. We can also compensate individual distributions separately. This allows us to treat the shrinkage factors for chord and thickness separately, as well as pitch and skew. I'm now entering in the shrinkage factors for thickness, chord, diameter, and the hub. However, I'm going to leave the skew factor alone. The idea being that the chord lengths are going to shrink inwards, and we do not have to actually compensate the skew in this particular case. However, we will compensate the pitch. I hit calculate again, and we should see our model refresh and become even more expanded. Zooming in, we can see that the wireframe is offset a decent amount from the original design. We can now save this file and export it to our CAD program of choice. I hit yes to accept the changes, and we'll see our final pattern brought into PropCAD. Again, we can manipulate this pattern just as we would any other propeller in PropCAD. From here, we can export our favorite CAD programs. We can save just an IGES. We can save this as a PropCAD file for later use. It's very flexible. And now let's compare the different geometries that we generated. I'm going to pull up Rhino, which has a preview of the exports. Here's our original propeller geometry. What I'm going to do is I'm going to overlay our machining geometry on top of the original geometry here. We can see that it's expanded and that it doesn't have the bore for the hub. Hopefully you can see that it is enlarged. And now I'm going to overlay the pattern geometry on top of this as well. So we can see that the pattern is even larger than the original machining model or the original propeller. That we have correctly compensated this, this geometry to create a pattern now. And we can do it quickly and easily. If we find out that the pattern is not suitable, that it needs to be adjusted, it's very easy to go back into our original design file, and we can open up our pattern utility one last time and see our existing factors will all still be listed. And we can also go in and adjust any of these factors based on what we detected after the initial casting process. This allows us to iteratively correct our patterns in order to make them more and more closer to the final form of the propeller. That concludes the demonstration within PropCAD. We're going to go back to the PowerPoint now. So to just review what we just did within the pattern corrections utility, we specified individual stock for the face, back, the outline, as well as the hub. We then saved it as a machining model so that we could use that as the stock model for generating CNC tool paths or robotic polishing methods. Then we added our shrinkage factors, and this allowed us to create our pattern geometry. So some interesting things to review and to pay attention to. The stock that we added to the propeller surfaces, this was specified for the face and for the back. So just realize that we didn't add 1/8 of an inch to the total thickness. We actually added 1/4 of an inch, because we added 1/8 of an inch on the face and 1/8 of an inch on the back. So just be careful that you don't double up on the stock offset. The tip method, the extrapolation method is best for wide tip propellers such as Kaplan style blades or nozzle propellers with wide tips. The simple method is best for round tip propellers like we saw in this example. And again, that's due to the converging of the chord lengths at the tip and the complex surface extrapolation. We can also correct for pattern maker shrink, and we can correct distributions such as chord and thickness individually from skew and pitch. And compensations for skew and pitch are dependent on the material, the casting process, the facility, and also the propeller geometry. Highly skewed wheels are going to have greater correction, and pitch can also be dependent on what material it is. Some materials will distort or lose pitch more than others. And once we've finished correct a design in PropCAD, we can always do manual and nonlinear corrections, just like any other PropCAD project. So in conclusion, PropCAD Premium includes new utilities for creating patterns. And these patterns can be compensated specifically for a material and a facility's casting process. It allows us to easily document our materials, our factors, and our stock offsets so that we can improve our pattern over time. And there are 3 primary geometries that the pattern utility can be used for. Once we have our design, which is our drive surfaces, we can create a machining model, which is the CNC stock model for generating the tool paths. And we can also generate a pattern by including the shrink factors, which will allow us to create a mold cavity in order to pour our molten material and cast our propeller. So in conclusion, again, the pattern corrections utility allows for the thickening of individual surfaces. We can thicken the face, the back, the outline of the propeller, and the hub length and diameter. The pattern utility includes methods that allow us to extrapolate chord lengths and tip geometry, not just scale them. And we can compensate individual distributions, skew separate from pitch, separate from chord, and separate from thickness. All of our settings will be saved back to our file so that we can document them, and alter our designs in the future. I think we've already talked about this, but PropCad has been around for over 15 years. We have 150 users in 40 countries. And with the introduction of our PropCad Premium package, we're looking to support more manufacturers and go beyond just designing a propeller. We really want to help people with inspection processes and creating patterns and getting good, accurate geometry. Lastly, I just want to talk about some upcoming events. Tomorrow in Portsmouth, New Hampshire, we'll be doing a presentation for SNAME New England on a bulbous bow retrofit. Don McPherson will be giving that presentation. Obviously, if you're in the area, we would love for you to attend. Next week, on Wednesday, we'll be doing another webinar similar to this, but we'll be discussing another PropCad Premium feature called Scan Converter. This allows us to extract the distributions of chord lengths, thicknesses, pitch, and section shape from a scan digital model of the propeller or scan data. Lastly, in March, on March 17th and 18th, we'll be doing PropCad Best Practices training in Durham, New Hampshire. The first day will be focused primarily on PropCad, the standard edition features, generating a design, generating drawings, using templates and custom files. The second day will be focused on Scan Converter and the pattern corrections, as well as the other PropCad Premium features. If you're interested, there's more information on our website, hydrocompinc.com/PropCad Best Practices. Of course, you can always view our trade show schedule and our online webinar training schedule from our website. With that, I want to thank everyone, and I want to open up the discussion here for questions. If anyone has any questions, they can type them into the chat, and we can pull them up in the chat window. Of course, you're always welcome to contact me directly and privately at my email address or over the phone. And I'm happy to answer any questions about PropCad or PropCad Premium and answer as many questions about castings and pattern making as I can. I appreciate all your time today, and I look forward to having a discussion. One question I've been asked is, will it compensate correctly for cupped propeller models? We can offset the surfaces directly, and it doesn't matter whether the propellers are cupped or not. Now, there may be some additional manipulation needed for a cupped propeller in order to have the cup form correctly. And this is really getting into more of the distortion idea. If I can pull up a slide here. As the propeller cools, there's going to be a little bit of warpage in the geometry. Now, a cupped section can be complicated. That the shape of the cup is really important. So, will it compensate correctly? Not initially. However, I believe that you can get it to be the correct geometry with some trial and error once you realize how the casting process affects the shape of the cup. I have another question here. Does it offset each face, or does it split the offset? So these offsets are specified specifically per face. So if we add 1/8 of an inch to the face and 1/8 of an inch to the back, we will have a total added thickness of 1/4 of an inch. The hub face offset functions the same way. It's if I specify a 1/8 of an inch for the hub face offset, it's going to add it to the front face of the hub and the aft face of the hub. So it won't be split. It will be a true dimensional offset from the surface. I'm happy to take any other questions that anyone has. Feel free to send them through the chat window. I'll stay here for a few more minutes and we can discuss it. And any other subsequent questions we can handle through email. I'll type my email again into the chat window here. Yeah, thank you, everyone. I appreciate you joining me today. I'm looking forward to next week's webinar on Scan Converter, and I think it will be a good another good webinar next week. Does it have a factor for droop of blades? That's an interesting idea. So you're talking about more or less a rake correction. It doesn't currently have a factor for the droop of blades, but I think there's probably some corrections that could be done. The issue is that it's very specific to, first of all, the size of the propeller and the weight of the blades. Larger propellers are going to have heavier blades. That's going to put more forces on it. But it's also very specific to each individual foundry's setup. How long do they leave the casting inside the mold? Typically, the longer you leave it in the mold, the less problems you have with drooping of blades. But it would be something that we could compensate using a rake correction. That's a good question, Wayne. Thanks. And now I'm curious if the rake correction is in here or not. Yeah, there is no compensation for rake right now, or droop as you're calling it. But I think that's something we can probably add. I'm going to make a note here. That's a good idea. Hi, Tony. We are recording this webinar. It will be available to watch on our website later today. And as far as the presentation is concerned, I'll contact you by email. I'll send you a copy. I believe if you registered through the Any meeting, I'll have your email, Tony. So I'll make sure that you get a copy. I really enjoyed presenting to everyone today, and looking forward again to presenting next week on Scan Converter. If there's any more questions, please send them, or send them by email later today, and we will conclude this webinar for now. Again, thank you all for joining me. Is 2016 ready for download? Yes, 2016 was released in I think mid-January or so. I'm not sure really on the date, but I know that it is installed on this computer here, and it is available for download on our website. I can make sure that you get a copy of the download link, Wayne. All right, thank you all for joining me. I'm going to stop the screen sharing session now, and have a great day.